Alrighty, hi everyone. It looks like we are officially live. So hello, and welcome into today's program. It is 11:01 over here in Santa Cruz, California. So thank you all so much for your patience. But we are going to give folks maybe another 30 seconds or so to jump into today's live stream, get settled in before we officially get started. So hello and welcome. We are so excited to see that you are all joining. So welcome. Alrighty, and as we are waiting for the next 30 seconds or so, please feel free to go ahead and say hi in the YouTube live chat, introduce yourself, say where you're tuning in from. We love to see where Seymour Center supporters are watching, and even during the conversation, maybe you can get a shout out from myself and Dr. Stephanie Brodie during the conversation. So hello. Alrighty, well, I think it is officially time to get this program underway and get started. So hi everyone, and welcome to a very special Labside Chat with the Seymour Marine Discovery Center. My name is Jen, and I will be your host for today. If you have seen a Labside Chat before, welcome back. If this is your first time tuning in, we are so excited that you're here. And to set the stage and to give you something to expect, you can expect to see a Q&A style discussion with a scientist from UC Santa Cruz to really chat about how scientific research plays a role in the understanding and conservation of the world's oceans. So I'm so excited for today's conversation because we are joined by the wonderful Dr. Stephanie Brodie, who is a project scientist at UC Santa Cruz and a researcher with the Fisheries Collaborative Program. So Stephanie, thank you, or I should also say Steph, thank you so much for being here and sharing a part of your morning with us today.
Of course, thanks for having me.
Awesome. So I am so looking forward to asking you tons of questions and learning more about your research. But before we dive into those questions today, I do have a couple of thank yous right up top for the folks watching at home. So first off, I want to give a huge shout out to UC Santa Cruz's Fisheries Collaborative Program in partnership with the National Oceanic and Atmospheric Administration Southwest Fisheries Science Center for sponsoring today's chat. So thank you so much. We are so grateful for your support. Additionally, I want to also say thank you to everyone who submitted questions in advance for Stephanie. Y'all are so awesome because there were so many questions submitted. I hope we have time to get to them all. But if you didn't get the chance to submit a question in advance, not to worry. You can always submit a question in the YouTube live chat feature, and we'll be able to get to those too. So I really don't think there's really any more time to waste. So Steph, I hope you're ready. There's going to be tons of questions coming your way, but I say let's just go ahead and dive right in. Alrighty, so Steph, I understand that you are a marine ecologist trying to figure out how change influences different species in the ocean. So can you explain some of the questions you are trying to answer with your research?
Sure. So I'm a marine ecologist, as you said, but I'm really interested in the spatial distribution of species. And a lot of my research is focused on fish as case studies. And that's in part because I'm really interested in fisheries implications for my research. So when I'm kind of considering the spatial distribution of where animals live, where they move and why they go there, I'm mainly interested in thinking about the environmental responses or the environmental drivers behind these animal movements. And in particular, I think the ocean is such a fascinating place to kind of examine those environmental drivers because we are so data limited.
Definitely. And so when you say spatial distribution, where animals are living out in the ocean, are you focusing on a specific part in the ocean? Are you looking at all different ecosystems? Are you looking close to shore, way offshore? Where are you mostly looking at?
The pelagic ocean, so open waters from the surface to the seafloor. most of the animals I kind of work with are more in the upper part of the water column in the surface waters. And many of those animals move long distances. They're highly mobile, highly migratory, and it's these kind of large movements and the environmental kind of drivers behind them that I find really interesting.
Yeah, and so these animals that move out in the pelagic ocean, out in the open sea, they're highly migratory. And so what type of animals are we talking about here? Are we talking about whales? You said fishes, but like what type of fishes? Just give us an idea about what type of animals that you are really focused in on.
Yeah, so I think most people would be familiar with whales as being highly migratory, highly mobile species, but there's also sea turtles and lots of fish and shark species. So for example, with fish species, it's lots of tunas and billfish, so things like swordfish and marlin, as well as lots of pelagic sharks.
Yeah, and I can't even imagine starting to study these animals because, like you said, they are highly migratory, they're out in the middle of the ocean, and you're trying to understand where they're going. So this is a loaded question, but like, how do you do that? Like, what's the research that it takes to figure out where these animals are?
Yeah, that's a great question. And I think in part, that's one of the reasons why the pelagic ocean has kind of drawn my attention, because we don't know a lot about it and the animals that live within it, because it's incredibly hard to access. So finding data to describe where those species are and how they respond to the environment is challenging. And so there's a few different ways that we can get data. One approach is biologging. And so that's kind of attaching technology to animals and track their movements in real time. And there's lots of different techniques and equipment out there to do that. But we can also get a lot of information from fisheries data because these fishing boats are going out onto the high seas and they're seeing and collecting a lot of information and recording that data. And so that's a fantastic resource and one that I use quite a lot in my work. There's also fisheries independent data. This is kind of the generic term. And so that's things like surveys, dedicated scientific surveys that will go out and explore the ocean and kind of sample what's out there. And they're the main kind of resources. But on the rise, I think, is opportunistic data. So things like citizen science programs or community science programs that are really gaining in traction, I think, around the world. And they're providing a really useful data source, I think, for scientists.
Yeah, wow, that would be so cool. So like I could go out there and I can help contribute, and help out maybe with some research and some sightings and whatnot. So that's very, very cool.
Absolutely.
So you talked about biologging, and that sounds super interesting to me. So that's putting technology on a species and you see where it goes in the ocean. So it's like tracking movements, or what's going on there?
Well, there's a few different types of technology. So there are certain kind of satellite tags, so you can have equipment on the animal and that's communicating with satellites and giving you a specific location of where that animal is. You can also have acoustic telemetry, and so these are kind of small little pingers that will kind of emit a sound every few minutes, and if they're detected on a receiver, then you kind of have that receiver's location and a known presence of that specific tagged animal. And of course, with they're the kind of two main branches. There's a lot more going on there, but all this technology has lots of different sensors, so that they can monitor an animal's movement, their depth, what the temperature is of the local water, and many more sensors, really. It's the technology boom, I'd say, over the last 20 years, 30 years has been incredible.
Yeah, definitely. And then you said that most of your data is coming from the fisheries data. So can you elaborate a little bit more on that and tell me what that exactly means? Because I'm just picturing like a boat going out to fish for tuna or something, or sardines, I don't know, and they're coming back with data. So what is that like, or what does that mean?
Yeah, so there's kind of two different data sources there. So boats will go out and they will record in their logbooks where they've fished and what they've caught, and they'll come back to port and then record what they've kind of landed at the port. But in a lot of cases, there's also fisheries observers on board, and so they're kind of an independent person that sits there and records all the animals that come on board. And so that observer data is kind of this independent validation source that's very robust. And so that's kind of the preferred choice of fisheries data, is this observer data.
Yeah, okay, gotcha. And then you also said that you're really interested in figuring out how change, whatever that may be, environmental change, climate variability, et cetera, influences where these animals are found in the ocean. So we're figuring out where they are, you're getting all of this tracking data, but what environmental factors are you looking at that could potentially influence where these species are found?
Yeah, that's a great question. There's a lot out there, and we're somewhat limited by what we can actually sense in terms of remotely sensed information from satellites that are determining kind of what the sea surface temperature is, what the chlorophyll is of the water, which gives us an indication of kind of productivity and foraging strength for these animals. But in recent years, there's also a lot of data assimilative ocean models. So these are kind of large models that actually model oceans themselves and their physical water properties. And so being able to use output from that is actually really useful as well. And that is giving us a sense of what's happening beneath the ocean surface. And so because animals live in a 3D world, we want to have a good understanding of what's actually happening in their vertical habitats as well as on the surface. And so things like looking at the mixed layer depth, looking at stratification of the water column, primary productivity across the top of the water column. These are all really important variables for many species. And the relative importance of those variables, I think, does depend on what the animal is doing in the water. So if they're foraging or versus when they're breeding, there's kind of differences there as to that we need to take into account when modeling.
Yeah, definitely. And so have you noticed any, I would say, like current events or, you know, shifts in habitat? So for example, maybe like the blob that happened in 2015. Did that change anything about species distribution, or did that affect where these animals are found in the open ocean?
Absolutely. The animals that I kind of study are more on this migratory, highly mobile phase. So their distributions are incredibly dynamic, and the dynamic nature of that is inextricably linked with the environment. And so, yes, the blob had a huge impact on our ecosystems and particularly pelagic systems. And moving forward, kind of thinking about climate change and the impacts of climate change on these species distributions, we are expecting there to be quite large changes for these more pelagic, highly mobile species that are able to shift when the environment shifts. But of course, this kind of comes with these ecosystem impacts of that you need to kind of consider multiple levels and predator and prey dynamics as well. So if you have a predator that can move and a prey that can't, then you have a potential decoupling there that you need to think about.
Yeah, and I guess I should have defined what the blob was before we dove right into this question and started talking about it as an example. So Steph, can you give us just a brief overview about what the blob was and why it was so impactful?
Sure. The blob was a large marine heat wave that hit along the west coast of the US, and it kind of had I'd say catastrophic impacts for most of the marine ecosystems. And I would say we haven't really recovered from this marine heatwave event, and the ecosystem has really changed and hasn't kind of gone back to a pre-blob state at this stage.
Yeah, well, thank you for defining that. You know, I'm just so glad that we have folks like you that are continuously monitoring the effects of what happened all the way back in 2015 and to now. So we're really, really happy that we have you on the case looking at that and figuring out how that's affecting the ecosystem. So my next question is, you know, we are figuring out where these animals live out in the open ocean. We're figuring out how, you know, what environmental factors are impacting their distribution. And so we're learning all of this really cool information, but how is this information used after we learned it? You know, we do we do we present it to different stakeholders? Do we give it to different academia groups? Like, how is this information used?
Yeah, that's a great question. And I would very broadly say it's used in lots of different ways. And so science, I guess, has lots of different kind of underlying purposes when you kind of go out and start doing research. And so one of those big purposes is just a general description and understanding of the ecosystems that we have, especially this kind of relatively unknown pelagic system. But you also have research that's very dedicated towards meeting management goals, and in particular the US's Magnuson-Stevenson Act, and making sure that research is really applied in that nature. And so that's something I'm really interested in. And so a lot of work that I've been involved in has been kind of considering more dynamic management approaches. And so this is more thinking about how we can resolve potential bycatch issues by considering the fact that the pelagic ecosystem is incredibly dynamic. And so if we can kind of predict those dynamic features, then maybe we can better protect some of the species of conservation interest.
Mm-hmm. Mm-hmm. Definitely. So we got lots of questions about climate change and how we are predicting climate change to influence the distribution of highly migratory species. So can you elaborate a little bit more about maybe some of the predictions you have seen, or maybe some of the models that you've seen, and give us an idea about what to potentially expect?
Sure. Yes, so climate projections are kind of at the moment going out to 2100, but they are a scenario testing exercise. So it's not a kind of known truth that we're trying to predict out to 2100. So we do have a lot of uncertainty and a lot of range of kind of things that we're seeing out there. So my kind of focus on distributional changes in the pelagic ecosystem is really kind of showing, I think, a pretty common result of species moving more towards the poles and species moving deeper as well. But the magnitude of the change of those kind of distributional responses depends on the magnitude of the environmental change as well. So species that live on the bottom of the ocean have less magnitude of environmental impact. So they are experiencing changes and moving deeper, but they don't have to move as far relative to an animal that lives on the surface that's seeing a kind of much larger change in environment.
Mm-hmm. Mm-hmm. Yeah, that makes sense. And I actually want to go back to some of the data collection conversation we had earlier, because we are also getting lots of questions about so we understand how data is collected, but I think we're really trying to picture about what it's like for you to go out on a field day or a data collection day, and what it's like actually out in the field when you're there. So can you give us an idea about what you are typically experiencing?
Well, these days, my kind of research and kind of days as a scientist is actually at the desk, and I love it because I kind of can now get access to incredibly long historical data sources that are incredibly rich, and having that long history of information is critically important to understanding what has happened in the past and what might happen in the future. And so I love the fact that I can kind of lean on all the efforts of all these other scientists and researchers and observers who have gone out and collected all this data that I'm now able to actually analyze on my computer. So for me, a day as a marine scientist is actually more sitting at my desk, but I love it.
That's awesome. Well, it just goes to show you how collaborative this work is and how many people are involved in just studying this really vast ecosystem. So that's fascinating. And I'm so happy to hear that you love it. That's very, very cool. And I just have to think about like what your childhood was like and like what got you interested into this field, because it sounds like some of the most interesting stuff ever. So what was your pathway like getting to this point in time and becoming this awesome scientist?
Well, I grew up in a small coastal town in Australia, in New South Wales. And so I think just being exposed to the ocean every single day and just it being a complete mystery to me was really what started my kind of passion. And I've always wanted to be a marine scientist. There's no other kind of career path that I've ever wanted to go down. So for me, it's always just been making steps towards becoming a marine scientist. And that pathway has been somewhat serendipitous. You know, I never knew that I wanted to study pelagic ecosystems or highly migratory species, but as I kind of went through university, through undergrad, and through grad school as well, I think I slowly kind of just moved towards the space that I'm in now, and it's been fantastic. So yeah, I guess it's all kind of come from, yeah, my childhood.
Yeah, awesome. Well, I only have time for a few more questions left. I can't believe it, but I don't know how time is ticking away. So I have to ask, these highly migratory species, why are they migrating? Have we figured out the answer to that question yet?
Yes, I kind of generally think we do know that, and in part because migration is a really successful strategy for some species, because they will feed in one area in incredibly rich foraging grounds, and then they'll migrate to another part of the world where they'll actually breed. And so there's kind of mixed benefits there of potentially being a safer place and a warmer place to breed versus being able to kind of move to an incredibly rich foraging ground. And it's a very successful life history trait for many species.
Yeah. And I have to ask, just out of my own personal curiosity, do you have a favorite migratory species that just has a special place in your heart?
I really don't. I think it would probably change day by day, you know?
Yeah, speechless. I stumped the scientist. So great. Awesome. So we always get lots of questions from folks about how individuals can help support sustainable fisheries or help support conservation or help protect these migratory species. And so do you have any advice for folks to help?
Ooh, that's a very big question. I think there's lots of different ways that you can help. It can be even as simple as reading and kind of starting to try and educate, I guess, yourself about the different threats that are facing the ocean. And if there's one kind of particularly close to heart, then I think it's easier to get involved when you kind of, you know, have something that you're passionate about. But it can really vary. Like, you can volunteer for beach cleanups. You can talk to your family and friends about what is sustainable seafood. You can look into various sustainable seafood apps. So you can kind of have a better understanding about what you're eating when you dine out on fish. And that can be as simple as asking your waiter, what fish are you ordering today? And I think little actions like that can kind of make people think about, well, what is this fish? Where did it come from? Is it a sustainable source? And within the US, if it's kind of a local source seafood, I think it's more of a safer bet that it is a sustainable source of seafood, and you're supporting local industry as well.
Awesome. Well, thank you so much for sharing that. I know that I will definitely be taking notes on those actionable steps that we can all take to help support a more sustainable ocean. So thank you so much for sharing all of that. My next question that I have for you that we received was about bycatch. So we are curious what is bycatch, how it's defined, and the potential impact it has out on the pelagic ecosystem, on migratory species. And so I know this is another big question, but if you can just define what bycatch is and discuss, what role it plays in the ecosystem, and if we can use different management tools to potentially reduce its impact.
Sure. So fisheries bycatch is a kind of general term to describe species that are unintentionally caught in fisheries gear. And so those species can be thrown back into the water, and sometimes they're not. So it's more of kind of unwanted species catch in fisheries. And so it can be very varied. It can be fish, crustaceans, through to sea turtles, seabirds, marine mammals. And so over the last, I'd say 30 years, there's been huge kind of changes to help reduce bycatch across all fisheries. And many of those changes have been kind of more restricted to gear changes. So things like changing the shape of the hook can help reduce turtle bycatch, or putting up flags to scare away birds can help reduce seabird bycatch. There's also other management approaches where you can implement a closure around an area, and that might be for a few months at a time to protect a reproducing species, or it can be permanent in time and just kind of protect a specific area, something like an MPA. And so they're pretty common approaches to reducing bycatch, and they are incredibly successful. Even kind of implementing these spatial temporal closures, they're really effective at generally reducing fisheries effort, which in itself kind of reduces bycatch. So it's really important to kind of consider the trade-offs here between reducing bycatch, but also maintaining an economically viable fishery that's providing the US with sustainable seafood. And so that trade-off is very challenging to kind of understand, and it's very specific to each fishery as well. And so this is kind of where dynamic management can be really useful, because it's more about considering management closures that better match the timescales and the movements of the animals that they're trying to protect, whilst also maintaining this kind of economic viability for a fishery.
Mm-hmm. Mm-hmm. Yeah, definitely. Wow. So my last question that I have for you, because we are quickly running out of time, is I just can't get over how awesome your job sounds. So I have to ask, do you have a favorite part of your job that makes it all worth it?
I think the best part of my job is collaborating with other people. I think it's just incredible to be in the marine science world and really get to meet a diverse array of people who all study different things, and they all bring different kind of ideas and techniques and innovation to science. And I think that by far is the best part of my job, is really working with awesome people.
Yeah, definitely. I mean, the community that's out there just to help conserve our oceans and learn new things about species and just have a natural curiosity about the world, it's really, really inspiring. So, alrighty. Well, Steph, that is somehow all the time that we have today. But before we go, do you have a place online, a website, social media handles where folks can go to learn more about you and your research? And so, because I wish I could ask you 1,000 more questions, but unfortunately I can't.
Sure, yeah, I have a Twitter profile. My handle's at Dr. Steph Brodie. And I also have a Google Scholar account, which lists all my research papers, if anyone kind of wants to get into the nitty-gritty.
Mm-hmm. Awesome. So I am dropping those links in the YouTube live chat right now, so folks can go ahead and access those. Or I will also make these links available in the video description after we wrap up our Labside Chat here too. Awesome. Well, thank you so much again, Steph. It was such a pleasure talking to you, learning about your research and what you do. And again, it's just really, really inspiring to hear about all the great work that you're accomplishing. So thank you so much again for being here.
Thanks very much for having me.
Awesome, awesome. And so another big thank you to UC Santa Cruz's Fisheries Collaborative Program for sponsoring today's Labside Chat. And a big thank you to all of the supporters tuning in today. It looks like we had Jenna joining us, Edgar. We also have, folks tuning in from Michigan and Utah. So it's just really exciting to see where all of y'all are tuning in from. So thank you so much again for joining us. If you like today's chat, and if you're in the position to do so, I ask that you consider either becoming a member with the Seymour Marine Discovery Center or making a donation. You can find more information on our website, seymourcenter.ucsc.edu, or click on the links in the video description below. Everything's right there for you, so you can easily find it. But that's all that we have today. Thank you again for tuning in. We hope you have a great rest of your day, and we will see you next time. Bye, everyone, and take care.